Right, so now we're going to take a look at horizontal motion, and as we're going to see, horizontal motion usually involves friction along a surface, and if that's the case, then we're also going to have to think about the vertical forces as well, and you'll see that in the examples that we'll look at. We'll look at an example very similar to the ones that we would have seen in the first year course, and then we'll see how things bump up a little bit for the AP course, working our way beyond. So these pictures here show some different arrangements of forces, and the first two look like they're the same, but remember that the key factor here is which way the object is moving. So in the first case, if the object moves to the right, but in the second case, if it moves to the left, that would change the way that we think about F equals ma. In the first situation, we would set up our equation as F1 minus F2 because the F1 pulls it in the positive direction, so we list that one first. But in the second picture, if the object moves to the left, we would choose to write this as F2 minus F1. Now again, that is a choice that I suggest that then makes sure that A, the acceleration, sort of matches our intuition that a positive acceleration means speeding up and a negative acceleration means slowing down. So in these next situations, again, it's the same thing. This is how we would write this first one here, F1 minus F2, if our object is moving to the right. But if the object is moving to the left, then we would do it this way. So the F equals ma equation does not really tell you which way the object is or what the object is doing. It doesn't describe the motion. It describes what's affecting the motion. So again, I would suggest that you choose the positive direction as the direction of motion, whichever way V points at the beginning of the problem, and then be consistent with that for the rest of the situations. This last one is a case where F1 and F2 are equal to each other, and so we could just say that the forces add up to 0. You could say F1 minus F2 equals 0. You could say F2 minus F1 equals 0. You could just say F1 equals F2.